In the figure below, WXYZ is a rectangle with WX equal to 4 and WZ equal to 8. Point M lies on XY, point A on YZ, and angle WMA is a right angle. Areas of triangle WXM and triangle WAZ are equal. What is the area of triangle WMA? Well, let's do some labeling, and since the diagram is already there, let's just use that diagram. Hopefully I can fit everything in. So that's 8, they're saying. This is 4, and I'm going to need some labels. I'm going to call this A, and then therefore this would be 4 minus A. And then this I'm going to call B right here, and therefore that would be 8 minus B, right? Yeah, 8 minus B. Okay, now where do I go from here? Well, this is an important one. Those two are equal. So that means that 1/2, where's WXM here? WXM, 1/2 B times 4, which is basically the area, is the equivalent of WAZ, 1/2 A times A. Okay, so that means 2B is equal to 4A, and that means B is equal to 2A. Okay, so that means this would be 8 minus 2A, like that. And then if we need anything else, we can kind of put it later on. Okay, that's a relatively decent start. Now, we're going to use Pythagoras because of that right angle. So that basically means that WM, hold on, let me change colors here. I don't want to use red for the whole thing. WM squared plus MA squared is equal to WA squared. Okay, so that means, what does it mean? Well, WM I can actually have in terms of Pythagoras on WXM. So that would basically be the equivalent of 4 squared plus B squared using Pythagoras. And for MA, it would be 8 minus 8 minus B. Yeah, well, I guess I'll substitute it in later. Plus 4 minus A, all squared. And then the last one, WA, that would be 8 squared plus A squared. Okay, so then expanding this all out, and I'm tempted to have you guys do it, but I guess I'll just do it. 16B squared, 64 minus 16B plus B squared plus 16 minus 8A plus A squared plus 64. Oops, gotta put a equals in there. 64 plus A squared. Okay, you guys know this story, right? Collect like terms, blah, blah, blah. Okay, you guys can do that. So when you do, collect like terms and put it all on one side and reduce it to lowest terms, dot, 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 you will end up with this. A squared minus 5A plus 4. And it's your responsibility to do all that. And then this, fortunately, factors. A 4, 1, minus, minus. Now, if you look at the graph, or not a graph, sorry, a diagram, A is obviously less than 4. So A, the only valid option is A equals 1. If A is 1, then that means B is 2, because of B equal to 2A. So we are doing quite well here, and we need to figure out the area of WMA. Where is WMA here? Oh, that's the inner one. Okay, that shouldn't be a problem, right? So I think I can fit it all on one screen. Actually, we can do it quickly, very quickly. Since B is 1, sorry, B is 2. If B is 2, then the area of this guy would be 1/2 base times height, which is 1/2 4 times 2, which is 4. So they put the 4 there. And then the area of this guy, we know A is 1, so that'd be 1/2 times 1 times 8, so that's 4 also. And then this here, that would be 1/2 base times height. The base looks to me like 8 minus B, so that's 6. And then the height would be 4 minus 1, which is 3. So that's 9. And then the full area was just 8 times 4, which is 32. So to get the area of the inner guy, which is this one, it would just be 32 minus 4 minus 4 minus 9. And that, I believe, is 15. So there we go. That would be C. A group of 100 students from different countries met at a math competition. Each student speaks the same number of languages, and for every pair of students A, B, student A speaks some language that student B does not speak. Student B speaks some language that student A does not speak. What is the least possible total number of languages spoken by the students? Least possible. Okay. So we have 100 students, and we have a sort of scenario here. Let's think about this for a second. For example, you have student A and you have student B, right? So we're going to have to probably use the answer choices here and see which one works. They want the least, so let's start with the least and see if we can make it work. And let me explain it with an example. Let's say there were 9 students, or sorry, not 9 students, 9 languages. So that would be L1, L2, L3, L4, L5, L6, L7, L8, and L9. These are the languages. Now, for this to work, let's give an example. Let's say student A spoke 3 languages, L1, L2, and L3. And student B spoke 3 languages, L1, L2, L4. Now, does this satisfy our criteria, which is each student speaks the same number of languages? Yes, they both speak 3 languages. And for every pair, student A speaks some language that student B does not speak. Well, in this case, it's L3. Student A speaks L3, but student B does not. Next part, student B speaks some language that student A does not speak. Yes, because student B speaks L4, and student A does not. So it fits the criteria. But here's the thing. We have to make sure that this part is satisfied also. How? Well, what did we actually do there? We took from the 9 languages, we chose 3 to create this scenario. And what is 9 choose 3? It is 84. Well, that actually fails because that number needs to be greater than or equal to 100, because that's how many students we have. Yeah, because we have to create combinations for 100 students at least. I mean, if it's more, that's fine. Okay, no problem. I'm still going to stick to the 9 languages, but I'm going to actually now, instead of 3, I'm going to give them each 4 languages. So whatever, right? L1, L2, L3, L4, and then L1, L2, L3, and L5. So if you do this scenario, it will meet the criteria of the question. Now let's see what happens here. Then it would be 9 choose 4, and 9 choose 4 is 126. So that is indeed greater than 100. So this scenario would be possible, and we did it with just 9 languages. I'm sure you could most likely do it with all these other guys, but they want the least. So therefore the answer would be A. Positive integers x and y satisfy root x plus root y's root of 1183. What is the minimum possible value of x plus y? Well, if you want the minimum possible value of x plus y, we want x and y to be very close together, very close in terms of their range, because the farther apart they are on the number line, if x is here and y is way over here, we will not get a minimum value. But if they're close together, then we'll get a minimum value. So the closest you can make them is to make them equal to each other. Let x equal to y. So that means root x is equal to root y. And therefore, if we take that equation, we will get the answer we're most likely looking for. So this becomes root x plus root x is equal to root 1183. So that'll be 2 root x is equal to 1183. And therefore that would be, if you square both sides, 4x is equal to 1183. And then x is equal to 295.75. Okay? And therefore that's also the value for y. Now, but these have to be integers though. But let's just see what is x plus y. That was going to be 591.5. Okay, but that is not the answer because we have to figure out integers, and these are not integers. Okay, not a problem. I think we can, let's see here, approximate, I guess. Basically choose the answer that's closest to our approximation, and that is I believe this one. Because I don't think you're allowed to use calculators on the AMC 10, are you? I can't even remember. But regardless, you'll see that the 595 is closest to our approximation. So it should be B. A dartboard is the region B in the coordinate plane consisting of points x, y such that absolute value of x plus absolute value of y is less than or equal to 8. Target T is the region where x squared plus y squared minus 25 all squared is less than or equal to 49. The dart is thrown and lands at a random point in B. The probability that the dart lands in T can be expressed as m over n times pi, where m and n are relatively prime positive integers. What is m plus n? Okay, let's try to understand this question first. So put it on a coordinate plane. So here's x, here's y. Now the first thing I'm going to tackle is this guy right here. That one is a box like this. Not entirely drawn to scale, but you guys get the point. Where this is 8 up here, this is minus 8, this is 8, and this is minus 8. And the region in the middle is this, represents that inequality. So that takes care of that. That's the dartboard. So that is the, I guess the region. Well, let's just put it over here. I've got to explain this. So this is the dartboard. Dartboard. And then we have the target. And the target is a different equation, different inequality. It's x squared plus y squared minus 25 all squared is less than or equal to 49. So that basically means that we've got a circle. This is basically a circle here. It's a circle, I guess, of radius 5, I think. Yeah. If you have, like, I'll do it here, x squared plus y squared is equal to 25. That's basically a circle centered at the origin that has a radius of 5. Okay. So what does that mean for us? It means that we have to try to figure out where that is on this, in this graph. All right, so we have to then work with this guy here. If x squared plus y squared minus 25 all squared is less than or equal to 49, if we take the square root of both sides, then that would be 7 and minus 7, and it would be x squared plus y squared minus 25 in the middle, and then put the 25 on either side, and then that would be 32 and 18. Okay, so that basically means that the circle that's x squared plus y squared has got to be between a radius of root 32 and root 18. So I'm going to attempt to draw this. Root 32 is what, approximately? Root 32 and root 18. I think like 5.6 and 4.2. So that means something like this here. It's not going to be perfect, but something like this here. And then this guy right here. Yeah, that's what we're looking at. And then what's in the middle, that is our target, I guess. Or, yeah. Okay, so we have to figure out basically the probability. So the probability, P, would be the area of that shaded region, which would be basically pi r squared minus pi r squared. So the first r would be root 32, because this is root 32 right here, that point. Well, root 32 squared minus this point, which is the root 18. Yeah, pi root 18 squared. And then that's over the total area. The total area is the total area of the box, and that's just going to be, what would it be? Oh, I got to figure out, I can't, I got to figure out the side length. Okay, the side length, that shouldn't be too much of a problem. We know that we can use Pythagoras, so if that's the side length, s squared would be 8 squared plus 8 squared. So s squared looks like 2 times 8 squared. Right? 2 times 8 squared. And that's basically, s squared also represents the area. So 2 times 8 squared. Okay. So that's the answer, but we got to get it to lowest terms. There's 32 pi minus 18 pi. So that's what? 14 pi? And then all over 2 times 64. So in lowest terms, that looks like, to me, 7 pi over 64. Yeah, I think that's lowest terms. So this represents my m over n pi. So that means the m is 7 and the n is 64. And they want m plus n. So m plus n would be 71. And therefore, the answer is B. A list of 9 real numbers consists of 1, 2.2, 3.2, 5.2, 6.2, 7, and xyz. X is less than or equal to y, y is less than or equal to z. The range of the list is 7. And the mean and median are both positive integers. How many ordered triples xyz are possible? Okay, so a lot of casework here, but hopefully it will not be too bad. So we've got 1, 2.2, 3.2, 5.2, 6.2, 7, and then x, y, and z. Now I don't know what order this is in, but I just put it on the screen, and hopefully we'll figure it out. And the range is 7. And what else do we know? Mean and median are integers. Okay, so we're going to have to do some casework here, I think. So let me make a table. So I'm not sure how many cases we have, but let's start with 3. Because there's 3 variables here, and each of these we're going to have to make a decision as to where they go. And then we have x, y, z, that triple that we're going to have to figure out. And then the range, of course, that has to be figured out. And then the mean, a lot of things here. Let's see here. And finally, I guess the median, which is the middle value. And I think that should be it. So let's see what we can get. Okay. So first thing, we want to look at the range. So let's start with z. Let's say if z is my biggest, well, it is. If you look at that inequality, that's actually very important. Z is the biggest. So let's start off with what's the biggest I can make it. I can make it 8 because remember the range from the biggest to the smallest has to be 7, right? The range is 7 right there. So if the range is 7, that would be in this case 8 minus 1, which is 7. So okay, that works. And that means that the 1 is less than the x, which is less than or equal to y, which is less than or equal to 8. So that part has to be established first. And therefore the mean, you'd have to add up all the numbers. When you add up these guys, the total actually is 24.8. And then plus the 8 for the z, and then plus the x plus the y. And what else are they saying? The mean is an integer. Okay, so this is basically 32.8 plus x plus y. That divided by the total number is 9. There's 9 of them. That has to be an integer. Okay, the only way that's an integer is if this numerator is either a 36 or a 45. That means 36 or 45 for this numerator, this guy. Because if it's 36 or 45, it will be divisible by 9. Okay, if it's 36, then that basically means that x plus y is 3.2. If it's 45, that means that x plus y is 12.2. 12.2. Yeah. So therefore, now we have to figure out the median. We got to make sure that the median is an integer also. So we got 3.2. Let's see here. 5.2. 1, 2.2, 3.2, 5.2. Then we got 8 out here. We got a 6.2. Sorry, we have a 7 also. We have a 6.2. Okay, so the only way the median is going to be an integer is if we need to put an integer in there. The only way I think is if you put a 6 there and then 6.2, whereas these guys are representing the x and the y, this and this. So that means the x and the y were 6 and 6.2, and then that would mean they add up to 12.2. See, it's all casework here. We got to fiddle around with the numbers. So that means this would be 6, 6.2, and 8. Yeah. And that's how we have to do this. We just have to kind of fiddle around. Okay, let's keep going here. The next one is if you take this guy here and you put it all the way to the other extreme. So we look at x and we say that's got to be 0 because they're all integers, right? Let's see here. They're real numbers. Okay, they're not necessarily integers. They're real numbers. Yeah. Okay. That is how we have to approach this. Okay, so now let's see. What is the range now? The range would be, what's the largest? The largest would be 7 minus 0, and that's 7. So that basically means that 0 is less than or equal to y is less than or equal to z is less than or equal to 7. Okay. And then this part, the mean part, again, 24.8 plus y plus z this time. That has to be divisible by 9. So the only way that would be possible if that number is either 27 or 36. Because it can't be 45 because that's too high, because our numbers don't go up that high because of this inequality. So if it is 27, that means that y plus z is equal to 2.2. Correct? And that, if it's, what's the other one, 36, then that means that y plus z is 11.2. Okay, so now we got to figure out the mean. So let's put all these in. We have 0, 1, 2.2. We have a 3.2 in there. Then we got some number that we don't know yet. We have a 5.2 in there somewhere, right? Yeah, we have a 5.2. Then we have a 7 way out here, and we have a 6.2. Okay, so now we got to figure out what is y and z, fiddling around with these numbers here. And I think that we could get an integer if there's a 5, I think. A 5 and a 5 would go here, and then the remaining value to make it equal to 11.2 would be 6.2. So that would work. So that means this would be 0, 5, and 6.2. Okay, and then I think one more case, I believe. So we can immediately cancel out this guy. And I highly doubt there's infinitely many. So we can cross that out. And then we've got the next scenario, which is when the x is between 0 and 1. Now, at this point, the range would be... well, let's see here. The range has to be 7, so... So this time we're making z minus x equal to 7. And therefore, that most likely means that z is between 7 and 8, since x is between 0 and 1. Okay. All right. So we can just shift to the median part. X is the smallest this time. Then we have the 1, the 2.2. We have the 3.2. Then we have this median. And then we have the 5.2, the 6.2, the 7, and then the z. So what can we do here? Well, we got to do the mean, right? The mean is 24.8. So, as before, that 24.8 plus, in this case, we have x plus y plus z, because we don't know anything here. But this actually helps me. I'm going to let it equal 4 for now. And at least that'll help me get something. That'll be 28.8 then, plus x plus y. And in order for this to be divisible by 9, that has to be 36. So that means that x plus y, or sorry, x plus z, sorry about that. X plus z is going to be 7.2. So these two equations, if we add them, we get 2z is 14.2, so z is 7.1, and therefore x would be 0.1. And that fits that. So that means this one is 0.1, 4, and 7.2. So there we go. Painstaking question here, and we got 3 possible solutions, and therefore the answer is C. Jerry likes to play with numbers, and one day he wrote all the numbers from 1 to 2024 on the whiteboard. Then he repeatedly chose 4 numbers on the whiteboard, erased them, and replaced them by either the sum or their product. After repeatedly performing the operation, Jerry noticed that all the remaining numbers on the whiteboard were odd. What is the maximum possible number of integers on the whiteboard at that time? Maximum. Well, 2024, that's how many numbers, right? And we are told that they're consecutive. So half of them are going to be odd. And of course, the other half are going to be even. Now our goal is to get rid of all even numbers. That's our goal, correct? Okay, so, and the way it works is that, let me go back here. He chooses 4 numbers, erases them, and replaces them. Yeah, then he repeatedly chooses, and after repeatedly remains the odd maximum number. Okay, I got it. So what he's doing is he's taking these even numbers, 4 at a time. So that means there's 253 times that he's doing that operation or move. Yeah, operation. It's actually called an operation. Okay, I got it. I think I have an understanding of this question. And then every time he does an operation, he has to replace it with something, either the sum or the product. Now, if they're all even, then their sum will also be even, right? 4 even numbers, if you add them, their sum will be even. Now, 4 even numbers, if you take their product, it will also be even. So when he removes 4, he's going to add back 1 even number. Does that make sense? So, okay, this is a cat and mouse game here. So let's just go with it. I think there's several iterations. So the first 253 times, he makes this move. The first 253 moves, he added 253 even numbers. Correct? He removed 4 at a time in each operation, and for each operation he had to add then an even number, because either the product or the sum will be even. Then he does this again. He takes those 253 even numbers, and 4 at a time he removes them, and that's about 63. So that means 253 even numbers minus 4 times 63, and that's 1. That's how many even numbers are remaining after he removes them all. But each time he removed 4, he had to add back an even number. So you had 1, but then you had to add back a whole bunch of you had to add back a whole bunch of even numbers, and there was 63 even numbers. You had to add back 1 even number for each operation. So now you're back to 64 even numbers. So let me just put a box around the even numbers, and our tally hopefully will get smaller and smaller, and eventually hopefully the number will get down to 0, and then when it does, we have only odd numbers left. Okay, so same thing again. 64 divided by 4, that's 16. That means of the 64, you removed 4 times 16, and then you added 16 because of this rule that you have to add, and that I believe is 16. Okay, so you're back to 16 now. Then again, 16 divided by 4 to count for the operations, and that means you had 16, then you removed 4 times 4, and then you added 4 new ones, and that brings you back to 4. Okay, so that's 4. Now we have 4 even numbers. We're going to move them all in one shot. That's going to be 1, and then that means 4 minus 4 times 1, and then you have to add that 1 even number. So now we have 1 even number. So now at this point, we have 1, 0, 1, 2 odd numbers, because those odd numbers are just sitting there, that we haven't done anything with them. plus one even number. Okay, now we still have to get rid of this guy because we want all even numbers gone, correct? All the remaining numbers on the whiteboard were odd. Okay, so now the only thing we can do is remove 3 odd and 1 even. So for example, let's say we removed a 3, a 5, a 7, and a 2. The sum is what, 17? The sum of those numbers, I'm just giving an example. So the sum is odd, but the product will be even because there's a 2 in there. So the product will be even. So we want obviously to replace it with an odd number. So we replace with an odd because we don't want evens. Replace with the odd, and when you do, you had 1 0 1 2, you remove 3, so you're down to 1 0 0 9, and then when you replace with an odd, you add 1 more, so you go back up to 1 0 1 0 odd, and then all the even numbers are gone, 0 even numbers. So this is how many odd numbers you have at the end of doing this. So 10 10 is the answer, and that would be 8. In a race among 5 snails, there is at most 1 tie, but that tie can involve any number of snails. For example, the result of the race might be that Dazzler is first, Abby, Cyrus, and Elroy are tied for second, and Bruna is fifth. How many different results of the race are possible? We will call them A, B, C, D, and E, and let's see what we get. Well, there's several scenarios, right? Let's say we can have all ties, 5 ties. We can have 4 ties, 3 ties, 2 ties, 1 tie, and I think, hold on here. There has to be at most 1 tie, at most. 5 snails, there is at most 1 tie. That tie can involve any number of snails. My wording is a bit off. I should put 5 snails. These are names of snails? Yeah, so 5 snails. These are not people. 5 snails tie. That's what I should say. 5 snails, 4 snails tie, or 3 snails tie. This is a 3 snails tie scenario, right? These 3 snails are tied for second, so that's this guy. Or 2 snails tie, or 1 snail tie basically means that's not a tie. 1 tie means no tie, nobody ties. That's basically what that means. I know the wording is not perfect, but hopefully you'll understand what I mean once I start explaining all of this. Okay, so here we go. Well, 5 snails tying, meaning they all tie. They all reach the finish line at the same time. So A, B, C, D, E, all reach the finish at the same time. Okay, there's only one way of doing that. So we'll just put a total here. Total ways, I guess, or possible. Total results, I guess. Total ways, total results. You guys understand. Okay, that was a pretty easy one. Now, 4 snails tie. I'll give you an example. So that means A, B, C, D, they tie. They get to the finish line at the same time. And E, I guess, is last. That's an example of 4 snails tying. So now we have to figure out the total number of ways that happens. Well, from the 5 snails, you choose 1 that did not tie, who not tied. So in this case, it was our E. And that is 5. And also, we have to, in this scenario, what I drew here, he came last, but he could have come first. So for each of these scenarios, you actually have two possibilities. Either the guy who didn't tie came first, or the guy who didn't tie came last. So it's actually 5 times 2 is the total. So 10 goes here. Right? So for example, you could have E come last, and then A, B, C, D. Or you could have A, B, C, D, those 4 guys tied, and then E actually won the race. Okay, next one. 3 snails tie. So for example, A, B, and C, they tie. They reach the finish line at the same time, and E came last, and D came second last, something like that. That's just an example. So similarly, to calculate it, from the 5 snails, you choose 2 who did not tie. So in our case, it would be E and D. And then we have to figure out how many different ways there are for that to happen. And I think it's 6. Like, for example, you could have E, D, and then A, B, C, right? Which is the what I drew. But then you could also have, like, for example, D, E, and then A, B, C. And then similarly, you could have A, B, C in the middle, and then E and D on either side. A, B, C. Or you could have A, B, C who came last, and then E and D who come, I guess, first and second. So as you can see, like I had originally thought, 6 different permutations. So then you take this 5, choose 2, and multiply by 6. And 5, choose 2 is 10, I believe. So it'd be 10 times 6, which is 60. So let me just circle our running numbers here. All right, moving right along. 2 snails tie. So an example would be A and B, they tie. And then the other 3 guys, C, D, and E, finish in some order here. So very similarly, from 5, you choose 3 who did not tie. And 5, choose 3, I believe, is 10. And then now you've got our permutations. You have A, B together, and you have C, D, and E. And I believe the permutations would be 4 possible places for the A, B, then 3, then 2, then 1. And you have to multiply them all. So 4 times 3 times 2 times 1, and that's 24. So you take this 10 and you multiply by 24, and that gives you 240. And then finally, 1 tie, that basically means nobody ties. So all 5 sort of have a separate finish like that. And then that would just be 5 times 4 times 3 times 2 times 1, and to get the number of different permutations, and that's 120. Okay, so we got to add this all up. So we got 120 plus 240, that's 360, plus 60 is 420, then 430, 431. 431 is the answer, and that's D. How many different remainders can result when the 100th power of an integer is divided by 125? Okay. So we have some integer to the 100th power, and it's divided by 125. Now, n we have no idea what it is, but 125 we know is 5 to the power of 3. Okay, so n is divisible by 5 or not. So if n is divisible by 5 or not, I guess those are the initial 2 categories, and there might be more categories. This is probably like the bigger one, but let's just deal with this one first. If n is divisible by 5, it's of the form 5k. And if that's the case, then we plug it back into here. It would be 5k to the power of 100 all over 5 to the power of 3. And let's see, that's going to be 5 to the power of 100 times k to the power of 100 over 5 to the power of 3. And that's just 5 to the power of 97 times k to the power of 100. So you get an integer answer, because remember, k is an integer. So the remainder here is 0. Remainder is 0. Okay, so that's one possible. How many different remainders are there? So one answer is 0. Okay, how many? So, okay, I got it. So we have to figure out how many other remainders are possible. Okay, how do we do that? I think this is a question that uses Euler's theorem, because we have to use it in order to solve this question without having to go through every single possibility, which would be impossible. So let me explain it to you. Euler's theorem. Okay, so it says that you have the greatest common divisors of two numbers, a and n, will be equal to 1. If it is equal to 1, two numbers that have a GCD equal to 1, then a to the power of phi, this is called phi or phi, however you pronounce it, is the equivalent of 1 mod n. So I'll explain with an example. So here we go, an example to make this clear. Let's say you have two numbers. Let's choose 3 and 8. Their greatest common divisor is 1. Correct? So that basically means that we need to figure out the phi of n. N in this case is 8. Now what is that referring to? It's referring to what numbers are coprime. Numbers that are coprime with n. And in this case, n is 8. Well, I think 1 is coprime, not 2, because 2 is divisible. 8 divides 2, so they're not coprime. 3, not 4, 5, 7, and I think that's it. Yeah. So basically you're looking at the number of positive integers that are less than the number that are relatively prime to that number. And in this case, that means that this is equal to 4, because there's 4 of these guys. So that means that if we go back to Euler's theorem right here, that 3, in this case a was 3 in my example, 3 to the power of 4 is the equivalent of 1 mod n, and n in our case is 8. And you can, since this number is relatively small, you can verify it. 3 to the power of 4 is 81, and 81 is indeed 1 mod 8, because if you divide by 8, you get a remainder of 1. So I think that's what we have to use. So let me keep this in the same screen here. So in our case, we've got n to the power of phi to the 125 is equal to the equivalent of 1 mod 125. So let's explore this. The GCD of n and 125 is 1 if n and 125 are relatively prime. Relatively prime. And if n is not a multiple of 5, because we already did the multiple of 5 guy, and we want to know if it's not a multiple of 5, what happens? Okay, let's see. So if we have the phi of 125, I have to find numbers that are less than 125, that are positive, that are relatively prime. So it'll basically be anything that is not a multiple of 5. So there's going to be 125 divided by 5, which is 25 numbers that are divisible by 5. So of the total numbers, you'd have to subtract those 25, and that would be 100. Okay. So this is equal to 100. So going back to Euler's formula, we would have n to the power of 100 would be equal to 1 mod 125. Yeah. So that means the remainder would be 1 when n is not divisible by 5, which was this guy right here. And that's it. Those are the only two possibilities. You either have a 0 or a 1 as the remainder. So we have two possibilities. So the answer is B. In the following table, each question mark is to be replaced by possible or not possible to indicate whether a non-vertical line with the given slope can contain the given number of lattice points, both of whose coordinates are integers. How many of the 12 entries will be possible? All right, so let's take this one step at a time here. I'll keep the table in the chart. Might as well just use that. Zero slope. So what does zero slope mean? Zero slope means that it is straight across, correct? Like this. This is a zero slope line. So let's say it crosses at 1. I'm just giving an example. So that means this line is the equation is y equals 1, or it could cross at 0.5. That means the equation of this line is y is equal to 0.5. Now let's go through these. Zero slope. Each question mark is replaced by a non-vertical line with the given slope can contain the number of lattice points. Okay. How many lattice points? Okay. Well, can it contain 0 lattice points? 0, 1, 2, or more than 2? Okay. I think I understand. First of all, lattice points is nicely defined there. Both coordinates are integers. Well, let's just concentrate on one of these lines at a time. Let's just look at the y equals 1. If y equals 1, then the x value could be 1, it could be 2, it could be 3, and so on. So you have a whole bunch of lattice points on that y equals 1. So this is a possible. So I'll put P for possible. You can have them infinite. But if we made a line that's y equals 0.5, then you'll see that the y coordinate is always 0.5. So you've immediately failed at creating a lattice point, because both coordinates have to be integers. No matter what x is, even if x was an integer, like 1, the lattice point it's not a lattice point like this point right here, because the y coordinate is 0.5. So you can also have a scenario of 0. But you cannot have exactly 1 or exactly 2. So those ones, is not possible. Okay, so that took care of the zero slope line. Now let's create a line that represents non-zero rational slope. Non-zero rational slope. Okay, so something like this or this. And let's just give an example. 1/2 x plus 1/5. This is a rational slope, and this is representing the slope. Okay, so if we have that, I think it's this line here, not necessarily drawn to scale, but that's okay. Okay, so let's discuss this one. If, let's see here, y equals x, that's another example where the slope in this case is 1. if that's the case, that satisfies a non-zero rational slope type of scenario. And if x is an integer, y is an integer, so you would have a whole bunch of them, so infinitely many. So that would definitely be possible. But for this one, you'll see that no matter what I put x in, even if x is an integer, y will not be an integer, because this 1 over 5 ruins the possibility of it becoming an integer. I think no matter what you put for x, I don't think it'll ever be an integer. And if you try to make y an integer, x will not be an integer. So that means 0 is possible. And then these scenarios are not. Okay, so now we move on to our last one, which is the irrational slope. And I'll give a couple examples here. So the first one, we have to put an irrational number, so put root 2. And then for this guy, we'll put root 2 plus a half or whatever. It doesn't really matter. Okay, so for this guy here, no matter what we do, we'll never get a lattice point. If you put 1 for x, for example, it'll never make y an integer. So 0 is definitely possible for this guy. But for this one, I think you can make a lattice point, and the only one I can think of is 0, 0. So that's the origin. So that would be in exactly one scenario. So that would be possible. And these ones are not possible for reasons I had already explained. So we have filled it out, and how many p's did we get? P's representing possible. 1, 2, 3, 4, 5, 6. So 6 is the answer, and that would be C. 3 different pairs of shoes are placed in a row so that no left shoe is next to a right shoe from a different pair. In how many ways can these 6 shoes be lined up? Let's make a list here. Let's say they're A, B, and C, and each has a right shoe and a left shoe. So the shoe that is labeled A, there's obviously 2 of them, and so on. Okay, so then now we have to create scenarios that follow the rules of the question, and then figure out how many permutations there are for each. So the first one would be L, 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 R, 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 like that. Now, the ones that are left, the ones that are beside each other, where one is left and one is right, they have to be the same pair. If they're not the same pair, then they fail the rule, the law, I guess, of this question. So in this particular case, we have 3 possible pairs to choose from. We can choose either this pair, this pair, or this pair. Then for the first L, we have only 2 remaining L's left. So we have 2 choices. And then for the second L, we have only 1 choice. Similarly, for the first R, we had 3. That's why we put a 3 there. But for the second R, we have only 2 choices. And for the third R, we have only 1 choice left. So the number of ways, number of permutations, whatever term you want to use, in this case would be 2 times 1 times 3 times 2 times 1, and that, I believe, is 12. And I'll give an example. I'll try to put an example. You could have the middle pair being the third pair. I know I put A's there, now I'm using numbers. It doesn't really matter. I mean, I actually probably just use L1, left 1, right 1, left 2, right 2, or left 3, right 3. And you can kind of ignore that. That's just, it doesn't really matter how you do it. It's just different ways. So you have 3 pairs. The first pair has a left and right. The second pair has a left and right. And the third pair has a left and right. So one example of this would be L3, R3 in the middle. And then on this side, L2, L1. And on that side, R2, R1. So this would be an example of that. Okay. So, and we'll circle the number of ways because at the end we have to tally them all up. We have to add them all up. So we're going to have a lot of ways here. All right, so I'll explain them a little bit. I'll explain them and then I'll just list them all because after a while you'll understand how to do it. So the other way is to have the R's in first and then the L's secondary. So similarly, these have to be the same pair, and there's 3 possible ways of doing that. There's 2 ways of getting the first R, the 1 way of getting that R, 2 ways of getting that L, and 1 way of getting that. So again, this is going to be 2 times 1 times 3 times 2 times 1, and that's 12. And an example of that would be, let's see, put the R3, the L3 in the middle, L1, L2 out here, R2, and R1 out there. So there you go. Okay, moving right along. The next one would be the R's in the middle this time, 1 L out here, and 2 L's out there. So these guys have to be the same pair, and these guys have to be the same pair. So you got 3 choices there, and 2 choices there, and then you just have 1 choice remaining for those guys. So it'd be 1 times 3 times 1 times 2, and that's 6. And an example of that is L1, L2, R2, R1, R3, L3. That's an example. Next one, we have the 3 R's together, and then L1, L's, 2 L's at the end and 1 L in the beginning. These have to be the same. These have to be the same. So 3, 2, and then 1 and 1. So again, 3 times 1 times 2 times 1, which is 6. And an example of this guy would be L1, R1, R2, R3, L3, L2. Okay. How many have we done so far? We've done 4, right? So hopefully there's not too many more. The other ones I'll list because I think by now you guys get the hang of this, right? So L, R, L, L, R. Same. So it's going to be 3, 2, 1. 3 times 2 times 1 is 6. And then an example would be L1, R1, R2, L2, L3, R3. Okay. And we got a few more. And let's see here. The next one, R, L, 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 R, R. This is the same. That's 3. That's 2. That's 1, 1. 3 times 2, 6. An example of that, R1, L1, R2, L3, R3, and R2. And then the second last, R, L, L, R, R, L. So this would be 3, this would be 2, and this would be 1. So 3 times 2 is 6. And an example of that one is R1, L1, R2, L2, R2, R3, L3. And final one is R, R, L, L, R, L. These have to be the same. So 3, 2, 1, 1. And that again is 3 times 2, which is 6. And an example of that is R1, R2, L2, L1, R1, R3. Okay, then tally all these guys up. And when you do, you will get 60 as the total. And therefore, the answer is A.